Continuing on and calculating the standard cell potential or the non-standard cell potential, let's do sample exercise 20.12. So you have a zinc and H plus cell. So I wrote the equation. Zinc is turning to zinc plus 2. That means it's giving away 2 electrons. And zinc is being, what do you think, oxidized or reduced? You're right, it's being oxidized because the electrons being removed from it. And hydrogen, this is the H plus right here. I'm put 2 there because it's making hydrogen gas, and it is being reduced as it takes in the 2 electrons from zinc, and this is being reduced. The cell potential of that is 0 if you look it up on the chart. This is the anode, and this is the cathode. So the E cell is equal to cathode, which is 0, minus the anode, which is negative 0.763, which makes it positive 0.763. Okay, now we are going to write the equation again. So I'm going to write zinc plus 2H plus makes zinc plus 2 plus hydrogen gas. Okay, so this is a solid. You don't put that into the K equilibrium expression. This is aqueous, and this is a gas. Okay, and so they told us that zinc plus 2 is 1.0 molar. And let's see, this is actually H2 gas. I know it's missing right here. This is H2 gas is 1 atm. What is the concentration of this? So you're solving for this. And this cell potential has a potential of 0.45 volts. So this is E, but without the naught. So it's non-standard. This is E naught. Okay, so the formula is E cell is equal to E naught minus 0.0592 over N log of Q. So here they gave us the cell potential at non-standard conditions, which is 0.45 volts, is equal to, this is 0.763 at standard conditions, minus 0.0592 volts over N, which is 2 electrons, log of, okay, I'm going to solve for Q over here on the side. Q is equal to Zn plus 2 H2 over H plus squared. Okay, so this right here is Zn plus 2 is 1 molar. H2 is 1 atm. And you can use the different units. I wrote here that these actually are activities. So if you have the molarity divided by 1 molar, that's 1 activity. So what I'm trying to say is you can use them in the same formula even though they're different units. Okay, and then this is H plus, which is missing, x squared. Okay, so I'm going to go ahead and solve for, you know what I'll do? I think I'm going to plug in, solve for Q first, and then plug in these numbers, 1, 1, x squared. So let me just go ahead and solve for Q. It'll make it just a little bit easier for me. I'm just going to solve for Q right here. Okay. So I moved this all to this side. 10.47 equals log of Q. So I'm going to go 10 to the 10.47, 10 to the log of Q cancels this. So Q is equal to 2.95 e negative 10. Okay, I'm going to plug that into here. 2.95 e negative 10. Solve for x. And x should be 5.8 e negative 6 molar of H plus. Okay, so what that means is if I want a voltage of 0.45, and I have these values for zinc plus 2 and H2, I'm going to need a beaker that is 5.8 e negative 6 molar of H plus. Then I will get this voltage.